Hello. In this video we'll look at transferring data from Petrel to Velit in the 1.9 data exchange module. This is compatible with all versions of Petrel from 2014 onwards. Here in the background we see a Petrel model, and we're opening up the Velit DE from the Processes pane by double-clicking on the Velit icon. This opens up the data exchange program, and here we can select Velit and export to a new Velit model, and we get a window popping up whereby we can enter the file name as the new model name as desired. When we click on open, you see that we have the Petrel view on the left hand side and the Velit view on the right hand side, and I'm clicking on the well. We can see the wells in the project, the logs, and on the right hand side here we can see that we'll drag and drop these over into the corresponding display. So to do this, we just left click and hold and move this across to the folder, and you can see that the wells have been brought across here along with the corresponding data types. On this side of the screen we have the well curve section, and we can preference to have sonic logs then checkshots, sonic logs only, checkshots then sonics, and checkshots only. And as the table view preference, you'll see as we select the options here and scroll down, this will tick and untick the relevant selection options for the wells, and we can use this as a good handle on getting the data into your project exactly as you intend it to come in. If I just close up the well tree here, we can see the tops list, and we can drag and drop the tops across to the corresponding folder, and here we see that the tops that we're going to bring into the model. Again, we use the tick box system, so you can select them discreetly to turn them on and off depending on the data that you have in your project. In opening the surfaces folder here, we'll see that we have 7 layers, and we can click on make a new layer, and I'm clicking this 7 times, and as you can see the folder is populating with 7 layer folders. So what we're going to do here is drag and drop the surfaces from the left hand side into the corresponding time grid folder, and if I click on the grid selection option here, we'll see that we have the master lattice information as the coordinate XY information for the first grid. Now for this process it's a case of selecting each surface individually, and you'll see on the right hand side of the screen the pane updates each time you load a surface in. We get the corresponding surface loaded through. One useful thing that you can see that I've done in this project is prefix the name of the time grid with the words TWT1 through to 7, and this just means that they're in order so that it's much more efficient in terms of your time in bringing these in like so. So you can see that we've now got the 7 surfaces corresponded with their slots, and here we have the formation tops. So what we're going to do now is correspond the formation tops to those time grids. So here we're now looking at the name of the surface and bringing these in accordingly. Now on the right hand side you'll see that we've got the layer preference. So as these tops are coming in, you'll see that we have a series of different options that we can select, and these relate to the ability to plot the well and the corresponding layer definition that's being applied on this data import. The idea here is that we're going to get all of the data conditioned correctly, so that as you're building your model you're able to see if there are any issues with the data, and the software will flag these like so. So what I'm going to do here is just expand the screen like this, and you can see that we now have some pastel color coding describing our layer definition, and we can see here with this red flag in this column that there is an issue with the associated formation top. So we can click on plot page, and the values behind this are the corresponding values to make the graph that we're about to generate. And here, as you see, the console, the processes are just updating, and we have our well plot displayed on the screen like so. So what we see here is 5 wells. We see the layer definition by color, and if I just go onto the screen here and select 7, I can replot the page so that we have all 7 wells displayed per page. Now what you'll notice at the bottom of the screen here is that on the wells 6 and 7 we have 2 sections where they are white on the display, and these correspond to these 2 selections here whereby the formation tops are not assigned. So what we're going to do is read from the graph, the plot, and have a look at what the formation top is that we want to select, and here we can see it's the top Triassic. We can simply select the top down menu, and on here select the top Triassic, and we'll see that we've updated this display now with the corresponding blue section. So we can do this for each of the formation tops that don't correspond and plot the page again, and we can see that we've now updated our layer definition accordingly. So we hope this enables you to get a good handle on exactly what data you're bringing into the model, and you can also see the condition of your well logs as well. The next thing that we're going to look at is the use of loading stacking velocities into the data. And you'll see that as you drag and drop the volume across, as I've just done here, we open up on the right hand side the preference option for processing velocities. Now in the project we're able to have a look at the different folders that we have available, and within the data here we can export these to a new Velit model. As a note, with the processing velocities we're able to import RMS velocities, interval velocities and average velocities, and we're able to adjust the time increment in milliseconds and also the distance spacing units as the 3D output lattice. So all of this is possible on the screen on the right hand side, and it's just a selection option for you to choose the data type and the corresponding values. Once the data has been outputted to the software, you can have a look on the surface diagram here, and we can see our layer definition, and we have 7 layers in the model. So just expanding the model tree on the right hand side here, we can see the time grids for layers 1 and 2, and if we click on the well location up here we can see the display is shown. So here we're just having a look at that second layer in yellow. If we open up the flyout on the right hand side and show events from current to wall, we can see that we've got 7 layers defined in the model.